Hello everyone, welcome to another session of Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. So let's see what we have in this lesson. In this lesson we are going to study the math operations. And what do we usually do with the math operations, or what do we need the math operations for? So just like any other programming language, we always have the math operation. You must have seen that in your lessons, maybe in a C, C++, Java class if you have taken any course in that. Okay, so here it will not be very much different. But in PLC applications, how do we integrate the math operation? So there are certain times that within your PLC application, you may want to integrate some forecasting. You may want to carry out some inventory. You may want to do some data processing, some arithmetic manipulations to get estimations of goods, maybe after 1 month, after 1 year, and then the math operation also becomes very important in that case. Okay, so what are some of the math operations that we shall study? We will start with the addition operation, which performs addition, subtraction for subtraction, multiplication to multiply two numbers, division to divide two operands or two variables, modulus to get the remainder, increment to increment the operation by 1 or the data by 1, decrement to decrement the data by 1 in a particular location. Then we have the operate block, which we can perform customized math operation, customized arithmetic operation. So we can put in a formulation inside, and then the operate block will perform the calculation and give you a result. Then we will look at the use case. We are going to simulate some scenarios in our environment. Okay, so we'll start with the math operation. So the addition operation. The addition operation adds 2 or more input data. Okay, so this is an input data, and before addition we have this. So this is the addition block. It's going to add the first operand to the second operand. So before addition, that is when this enable switch is not yet closed, it's not yet true. We have at our input terminal 15 and 5. And when that logic here as PB0 becomes true, so the addition operation is now performed. So 15 is added to 5 and transferred to the output. You can see here our output is 20 and here our output is 0 because the addition operation has not yet been executed. Okay. Next is the subtraction operation. So the subtraction operation subtracts input 2 from input 1. Okay, so when the block is enabled, so when it's enabled, it performs the operation. So subtract 15 from 5 and gives you 10. But when it is not enabled, then the operation is not performed and the output stays where it is. Okay. Next that we shall see is the multiplication. The multiplication now multiplies two numbers or 2 or more inputs. Okay, and here you can see when we take before the multiplication we had 15 and 5 for our different operands. So the multiplication block is not yet activated, so the output is 0 by default. When it's now activated, that is after multiplication operation, that is after we have activated this switch. Okay, what happens is 15 is multiplied by 5 and transferred to the output. Okay, so you can see 15 times 5 gives us 75. Okay. Next we have the division operation. Okay, and in the division operation, that is the first operand. We divide the first operand by the second operand, and the result goes to the output. Okay, when the block is enabled. Okay, so here the block is not enabled, so we have 0. And here when the block is enabled, we take 15 divided by 5, gives us 3. Okay, so you should take note of the data type. The data type must always be consistent. The data types must be the same. Okay, we have discussed exclusively what data types are in an earlier session of this tutorial series. Please go there to understand data types and where they are used, where they are applicable. We have explicitly explained data types in an earlier tutorial. Okay. Then we have the modulus. So the modulus actually returns the remainder of a division of two numbers. So it also performs division, but in that case, it returns us a remainder. All right. So here the modulus operation is not, the modulus block is not activated. So we have 0 by default. Yes, activated, we have 0 as an output because 15 divided by 5 is 3 remainder 0. So that's why you see the result 0. If we had maybe 16 here, so we have 16 divided by 5, it's going to be 3 remainder 1, we would have had a 1 here. Okay, so we are going to see that in simulation. All right. Okay, then we have the increment block. So increment the data at the input by 1. All right. So this is the block representation of the increment operation. Okay. So here when the block is enabled, it constantly increments this. It constantly increments the data in there at the input, send it to the output, and then the next operation, the data is sent back as an input data. That's why you see in-out operation here. Okay, so before the block was enabled, the data at the input was 15. So you can see in-out 15. Now when the data at the input, when this push button is activated, so for one scan cycle, it has incremented the data by 1 and sent to the output, and the next cycle the data becomes the input. So that's why you have 16 at both sides of it. So it is an in-out variable. When we declare variable, when the variable is an in-out variable, okay, this is how we represent all this notation. All right, so don't be confused about it. So it's different from strictly input or strictly output. So it's an in-out variable. Okay, all right. And finally, we also have now the direct opposite of increment, which is decrement. So the data at the input is decremented by 1 when the block is enabled. So if I press this the switch for one scan cycle, the data will decrement by 1, and in the next cycle, the data at the output becomes the data in the input. Okay, so why have we not used a normally open switch like that? Okay, so it's because we don't want this to be constantly decrementing for every scan cycle. When this is true continuously, like for example, if we latch it and it's true continuously, it will progressively decrement the data by 1. Okay, so we just want it to decrement the data for every one scan cycle, that is whenever we press. So that's why we have used the positive edge contact. Okay, we have not used this. If we use this, it would decrement it. So let's say if the scan cycle is 1 milliseconds, for example. Okay, and if we use this contact, it means that for every 1 millisecond, it will decrement it. So before you even notice, oh, that it may have decremented all the data. We want it to only decrement when we push it. So for one scan cycle, it will decrement when we push. For another scan cycle, if we push, it will decrement for that. So it decrements only upon request from this input contact. Okay, good. So we have now 14 after it has been decremented. All right, hopefully that makes sense. Okay. Now we have the operate block. Okay, so in the operate block, we perform calculations, and we perform that calculation by having some predefined equation. All right, we have this predefined equation. You can clearly see that it's a predefined equation. Okay, and in this predefined equation, we are performing this operation on 2 times x times y plus x minus 5 times y minus x divided by y. Okay, so here you can see that initially the push button is not pressed, so it is 0. The value of z is 0 because it is the result of this operation. The value of x is 15, and the value of y is 5. Okay, and they are all of double int type. Okay, you can see their data type there, all of double ints. Now what happens when this switch goes high? When the switch goes high, what happens? When that switch goes high, then that operate block performs its operation, and when it does that, what happens? So you can see that they are up there, switch has gone high, what happens is that operation is performed using this formulation, okay? And if you do the math very well using your calculator, you will see that for value of x being 15 and y being 5, we substitute for x here 15 and y 5, and you evaluate this expression, you're going to have 137. So you can use it to perform complex calculations that ordinary add, subtract, multiply operation may not easily realize. Okay, so after having studied the different math operations, now let's see how we can utilize them in a software environment. Okay, so let's try to test the operations that we have studied. So to do that, I'm going to go to my Unity Pro software and open it. Okay, so I have already created a project for this exercise, and so what we are going to do now is we are going to study the different operations beginning from addition, subtraction, multiplication, division, modulus, increment, decrement, and the operate operation. Okay, so we'll start with the addition operation. Okay, so one thing you should know about this environment is that you can also monitor the different parameters. Okay, you can see where they are located by just highlighting the parameter and clicking on this icon which says inspect window. Okay, so there it will give you the variable and its location. So it shows that we have variable A is located at memory address MW0. Okay, variable B is located at MW2 and variable C is located at MW4. Okay, ABC is the same here, ABC is the same here, ABC here. Variable Z is located at MW6, E is located at MW12, F is located at MW8, G is located at MW10, and G is also located at MW10 for the decrement. Okay, so you can also see them by just going to your variable table. These are the different addresses which I have declared for this operation. Okay, so when we are not dealing with a bit memory, we are using the memory word. When we are dealing with a bit memory, we are using the memory bits, as you can see. And for memory bits, we have declared them as extended boolean, so we have to declare them as extended boolean. If not, we are going to have compatibility errors. While for some variables, we have declared them as real, some we have declared them as double integer. Okay, as you can see from the different data types. All right, okay, so let's go back to the programming environment. So what we are going to do is first make sure that your PLC is in simulation mode. Remember, we are not using a physical PLC. That's why we are using memory words and memory bits. So make sure you are on simulation mode. Okay, not standard mode. Not standard mode, simulation mode. So I'll put my PLC in the simulation mode. So it's asking me if I want to swap mode. I will say yes. Then I will now have to analyze the project. Okay, so if analyze the project, we have no errors. Then I will build the project. Okay, now I'm building my project. So my project has built successfully with no issues. Next, I'm going to now connect to my PLC. Okay, so it shows that the current program in my PLC is not the same as this program. Okay, so that's why you see here different. So I'm going to now override the program that is inside my virtual PLC with this actual program, and to do that, I will take a transfer to PLC, and then I want to run after transfer. So I'll confirm that. Okay, so my PLC is now going to the run mode. Okay, so from here you see that the values of A is 0, 0, so it's real type. That's why you see 0 dot 0, 0.0. All of them are real type. Okay, the data type must be the same. So that's why you see 0, 0. Okay, so the block is not enabled. Now our input is two inputs are 0, 0, so the output is 0. Okay, so what I will do is I'm just going to highlight this block and then click on it and take Initialize Animation Table. Okay, so I'll just rearrange this. I will close this, not useful, and I'll place these two side by side for upper view. Let me zoom this a little bit so that you can see clearly. Okay, good. So hope you can now have a good view. So for addition operation, now our A is 0, B is 0, so C automatically is 0, because one, we have not enabled this pin, so by default C becomes the default value of the real default value is 0.0. Okay, so I will just go to the modification mode, and then I will modify the A parameter to say, okay, for example, if we want to add, I'll go to the value, I will add take 20, so it's 20.0, and maybe say 30.5. all right. Now the values have changed, but the output has not changed because the block has not been enabled. Okay, so to do that, I will have to set this to high state. Okay, now it has computed the addition, and the addition has now given us 50. So you can see from our environment as well as from our animation table that our new value is now 50. So even if this push button goes back to 0, the output will stay. Okay, the output is going to stay like that. The output will not reset. Okay, so taking this to 0 does not update. For it to perform another operation, like if these values are modified, then this logic here must be 1. Okay, hope that makes sense. Okay, next we are now going to go to the subtraction. Okay, so you can see the subtraction block, because we are using the same parameters. That's why you see A, B, and C, they are all the same, but it is a result of the addition because the subtraction block was not enabled. Okay, so now I will disable the addition block so that it doesn't have influence on the operation on the result of C, and I'll have to now enable the subtraction, okay, enable parameter. Okay, so to do that, first I will just have to call it in my animation table, so I can browse for it. That is a PB1, so that's PB1. PB1 is 0. So now I want to perform subtraction, and if I enable the subtraction block, okay, I should now see what 20 minus 30.5, so it should give me minus 10.5. okay, if we had 30 minus 30.5 minus 20, we would have had positive 10.5. so if I now go ahead and enable this block, I should see minus 10.5. so I will push it to the high state. Good, so we now have minus 10.5. that's how we perform subtraction. So I will set it back to the low state so that it doesn't affect other operations. Next, the multiplication. So you realize that this result is coming from the subtraction, not the multiplication, because the multiplication block was not enabled. Okay, remember we are using the same parameters for all of them. That's why they can modify it everywhere around the program. So for the multiplication, now I will have to multiply 20 times 30.5. Okay, so what we are going to now do is just to set this high and observe the output. So it should be 20.5 times 20.0 times 30.5. so I will push too high, and to do that I have to first of all bring it in our animation table, that is PB0, PB2, and I'll set it high. Okay, good. So we now have 610. Okay, so 600 out of 10 is the result of 20 times 30.5. Okay, so again, I will push it low. Okay, the result does not change. Okay, so it's only another operation that will change the result. And remember that if all of these were 1 at the same time, okay, it's going to be modified at the last stage. Okay, so if it is 1 here, 1 here, 1 here, only the last operation will modify it, the last operation, which is the division operation. Okay, last operation will override all the other operations. Okay, so now division, also I will bring its variable here, and that is PB3. Okay, so PB3, I will set it high. Alright, so this is now the result of 20 divided by 30.5. You can set it low again, depending on you. So we can use this to control different operations, addition, subtraction, or whatever operation that you're carrying out. Okay, alright. So we now also have now the modulus. Okay, so for the modulus, we have operands D, E, and F. Okay, so I'm going to bring them in my animation table. So we have operand G, E, and F. So I can highlight them by just holding down the control key and selecting all of them. Okay, so you can see we have called them in the animation table. Okay, so I will set D. For example, I will say G to 330, and I will set E to say let's say 4. Okay, so 30 modulus 4. Let's see the result. I will have to also call PB4. So I will set it high. Okay, so you see 30 modulus 4 is 2. Okay. Alright, so that's the result of the modulus of 30. 30 modulus 4. And that is principally 7, remainder 2. Okay. Now for the increment, what I'm going to do is I'm going to pull the parameter G and PB5. So to do that, I will go to my animation table and I will select G and PB5. Then I'll bring it up. Okay, just like that. So now the initial value is 0, so I can give it whatever initial value that I want, but if I want to start incrementing from 0, then I will just have to set PB5 high. So I will push PB5 high. So you see it has incremented by 1. I push it low, I push it high again, it has incremented to 2, it has incremented to 3. So for whatever pause that comes to that enable parameter, this block will always increment the variable G by 1. So you can see I've incremented up to the value 13. Okay, so you can progressively do that. Okay, up to whatever value that you want. So now let's look at the decrement. So this was increment, now let's look at decrement. So for the decrement, we do the same. Okay, so to do that, I will first of all push PB5 to 0, the 0 logic, then I will now bring in PB6. So I will browse for PB6, I will pull it up. Okay, so when PB6 increment, remember they share the same variable, so this result is a result from the increment. If I push PB6 high, it will start to decrement the value G. So I will set it high, go, so it has decremented to 18, to 17, to 16, to 15, to 14, to 13. Okay, so that's how you can use a decrement operation. Okay, if you want to constantly increment a certain variable by 1 based on certain action, you can use this incrementation and decrementation operation. Okay, suppose you are incrementing, you are decrementing, you can use any of them. Okay, depending on the application that you're trying to build. All right. Hope that was clear enough. Now we have our operate block. Our operate block has parameter XYZ in this formulation, so I will call them into my animation table as XYZ, and I will modify this to 15, then I'll modify this to 5. And if I enable this block by activating PB7, so I'll bring in PB7 by setting PB7 to the highest state, then you realize that our Z is 137. Okay, all right. So this is how you can use different operations to perform arithmetic calculations. Okay, all right. So let's go back to our presentation. So in our presentation, okay, so our presentation says that you make a ladder logic program for the following equation. Use int as data type. For this, x should be 30, y should be 5. Okay, using the operate block. Okay, so what we just need to do here is to just go back to our environment and then just take x to be, okay, so we have already done that, which is this. So x should be 30 and y should be 5. So now we have a result of 299 as our z. Okay, so now let's further modify this. There's another function that we can make use of, or another block, which is called the compare block. Okay, so let's say that we want this operation to be carried out only when a certain condition is true. Okay, so in that case, I'll just enlarge this window. So I'll just modify this program. Okay, let's say we don't want to control it now with, the push button. Let's say we want to control it with some condition which is not necessarily a switch. So to do that, we'll delete this push button. We are going to bring in the compare block. Okay, sorry, we're going to bring in the compare block. We can pick it from here, compare, and print. So whatever we put here as condition, when it becomes true, then this operate block will be executed. Okay, so we want to modify it. Let's say we want that this operate block should function only when x is equivalent to y. So we are going to say if x is equivalent to y, then this condition becomes true, then this operate block will be executed. Otherwise, it will not be executed. Okay, so let's build a project again and see what happens as a result. Okay, so let's go to our animation table. Here I will just zoom this out a little bit. Zoom it in. Alright, so now you see the logic is false. So this data is coming from our previous operation. Okay, so z has not been updated. Why has z not been updated? Z has not been updated. Let me just turn this off. Z has not been updated because this condition is not true. But let's say that Z is, for example, now let me see, it's 5. So it becomes, X is now 5. So it becomes directly equal to Z. Good. So you see, the logic now becomes true, and this is executed. And then we now have the value 29 as our result. Okay, and in a case where we want it to execute only when they are different, then we can say, let's say that we should execute this only when x equals y, only when x is different from y. So when x is not equal to y, so it's just like a comparison operation that we can put whatever condition inside. Okay, unlike a dedicated comparison operations are already predefined, just need to use them. But here you can define the way you want this compare block to function. Okay, so I will say okay, I want to modify yes. Again, I will have to build the project. Yes. Okay, so here you can see that x and y are the same, so this value is not updated. All right, so let's say that our x is now 5, and let's take our y to be something, say 1. Okay, so now the logic becomes true because x and y are not the same, and it is now executed, and our result is 5. Okay, hope that makes sense. All right, so let's go back to the presentation. Okay. All right, so you should know that there are several other math functions that you can use depending on the application that you are building, ranging from square root, natural log, common log, exponentiation like exponential value, sine, cosine, tangent, arctant, arccosine, arctangent, exponential real, that is a number raised to another number, absolute value, sine, evaluation, so it returns the sign, okay, sign evaluation, then negation, that is reverses the sign. You send a negative number, gives you a positive number, okay. And then we have averaging. You can average several operands, okay, you include several operands, and then it returns you the average, okay. All right, so that will bring us to the end of this presentation, the math operation. And then we have studied, understood how to use addition, subtraction, multiplication, division, modulus, increment, decrement, operation block, use cases, and other examples. Okay, so in the next section, we will be talking about the move operations. Okay, so please give this video a thumbs up if you like it, share it with your friends who are also interested in programming PLCs like myself, and subscribe also if you also want to get more projects or understand PLC, because we'll be uploading different PLC training sessions. Okay, so this is just one part of the series. So to stay tuned with us, please subscribe so that you don't miss any of our updates. And thank you very much, and see you in the next video.